Hello everyone, and welcome to your first video for this year in Algebra 2. Now, a couple things to talk about as we go through this. So a lot of times I may be posting a video like this where I'm writing on Notability and casting from my screen here. I could also do it by hand where I'm recording what I'm writing, or maybe I'm standing in front of the board. Regardless, when I'm posting videos, the point of this is so that way I'm, first of all, conveying the information that I need for you, and second, you have the ability to pause and rewind all of my videos. That's kind of the hope and the expectation for you, right? So if I'm working too fast, or if you are confused on a problem, pause, rewind, and go through that problem again. Or a lot of times I may say, okay, here's an example, pause the video, try this one on your own, and then see what I get at the end. So, while this is kind of working on your own, there still should be some collaboration back and forth where you pause it, you watch, or you pause it, you try, you watch my example. This shouldn't be you just sit and stare at my video attempting to learn something without copying anything down. So our first video here, we're going to talk about linear equations. So we're going to go back to Algebra 1 there. We're going to review this a little bit. So the goal is that you can solve a linear equation and then determine if an equation is always, sometimes, or never true. Now, when we are talking about solutions, when we're talking about solutions, I need to put that in a context for math, because in different places, like let's talk about chemistry, a solution is a mixture of different chemicals, right? But when we're talking about a solution in terms of math, it is a value or values we can substitute for a variable and it makes the statement true. So it's a value or values that we can substitute for a variable and make that statement true. And I'm going to put, let's say I'll put like a little swooshy marker on it, because that's kind of a definition for us. Now, when we're talking about solutions, there's like two different ways, right? Like I could have a linear equation where if I put the equation x plus 14 is equal to 18, I know that x is going to be equal to 4, right? I've solved for x there. That means that this is the solution. If I were to plug this in, it would work out, right? So in terms of a linear equation here, there's just one solution. But if I am talking about, let's say, an inequality, so a linear inequality, let's say I had x minus 3 was less than 12. Well, if I solve here, I'm going to have x is less than 15. And if I were to shade this on a number line here, 15 being over here, and x is anything less than it, there's actually like infinitely many solutions for this, because it could be any number that's less than 15. It could go all the way to negative infinity. It doesn't really matter as long as it fits in to what our solution is. So you could have one solution, or you could have infinitely many solutions. So let's look at a couple examples as far as like linear equations that we will come across. So our first one here, say we'll call this example 1. The problem is 5 minus 3 parentheses 4 minus 2x is equal to 3 parentheses x plus 2, that's a plus, minus 14. So do this for me. Pause the video here, try this problem on your own, and then when you finish, see what I'm going to get. I'll give you a second. All right, so hopefully you were able to work through this problem. Now, one of the biggest mistakes that I come across with students understanding here is that the first thing you have to do is distribute. A lot of students always want to combine these like terms because they see 5 minus 3 and they turn that into 2. But remember your order of operations, multiplication always comes before addition or subtraction. So I actually want to distribute this negative 3 inside to my parentheses, as well as over here I can distribute this 3 inside my parentheses. So my next line, I have 5 minus 12 plus 6x is equal to 3x plus 6 minus 14. So always distribute first. Now from here, we need to combine like terms. So notice I've got the constants here, 5 and negative 12. That gives me a negative 7 plus 6x. Nothing changes with the 6x. And then I also have 6 and this negative 14, and that will give me a negative 8. So I have 3x minus 8. And we're still going to work through this solving here. So let's go ahead and move our variables first. I always prefer to move the variables, the smaller to the larger, because then it puts your variables on one side and you know, okay, I'm going to move the numbers to the other. So we subtract 3x from both sides. Negative 7 plus 3x is equal to negative 8. And let's go ahead and add 7 to the other side. We're still solving for x. You get 3x is equal to negative 1. Now you want to get x by itself, and to do so, you are going to divide by 3, divide by 3. So we get an answer of x is equal to negative 1/3. Leave your answer like this. I know if you've had me in the past for class, I always stress, I don't know why the box feature is not working here. Well, whatever. Guess I'm not going to box my answer. I'm going to circle my answer instead. Haha. So leave your answer as a reduced fraction. The reason being is that if you turn that into a decimal, that's going to be a never-ending decimal, right? Negative 1/3 would be negative 0.33333333333, so on and so forth, right? Some exceptions to that, let's say you had like 1/4. We know that's going to be 0.25. So if you converted it and it was a nice clean decimal where it terminates right there at the end after the 5, that would be okay, but still get into the habit of turning in your answers as fractions. It makes life a whole lot easier. So hopefully you got the same thing. Let's move on to another example here. So example 2, or I'm going to do it like this. Let's have x over 6 plus 2 over 3 is equal to 1/3 x minus 1/2. Now, I am going to move my variables and my numbers around, but yeah, there's fractions thrown in here, right? This x over 6, it's 1x over 6, so if you need to add that in there. So some of us, maybe need to use calculators to do this. I'm going to show you two different methods. So let's say I start off with subtracting 1/6 x from both sides. And then at the same time, I could also add the 1/2 to both sides as well. So what happens is over here, I get 2/3 plus 1/2, and that's equal to 1/3 x minus 1/6 x. Now you have to have some common denominators here if you're adding or subtracting fractions. So that means that for here, I need to multiply this by 2, both the top and the bottom, and then here I need to multiply it by 3. So I'm turning it into something over 6. So that gives me 4/6 plus 3/6, which gives me 7/6. That's just the left side there. Now I'm going to do the same thing on the right side, except this one I only have to multiply by 2 to the 1/3 because 6 is my common denominator. So I get 2/6x minus 1/6x. 2 minus 1 gives me 1. So 1/6x. And then those are equal. Now, you might notice that they have the same denominator, right? So 7/6 is equal to 1/6x, or you can make that 1x/6. What is it going to be? Now, if you can't quite pick up on the pattern, that's totally fine. But if I multiply by 6 to get rid of that fraction here, right, I'm just canceling out the denominator, I get 7 is equal to x. So that's one way to go about doing it. Now, you could use your calculator as well. So let's say you didn't want to do like this full step of converting it into a common denominator. I'll show you what it looks like with my calculator pulled up here. Now, when you're using your calculator, you have to put things into parentheses if you're doing fractions. So parentheses 2 divided by 3 plus parentheses 1 divided by 2. So this is 2/3 plus 1/2, and that gives me this decimal, which, you know, I wouldn't necessarily know what that is off the top of my head. But if you hit this math button here, so right under the second, the alpha, the blue and green button, this math button, and then the first thing that's selected is fraction. This should look the exact same as your graphing calculator if you have a TI-83 or 84, and even most of the other ones also look like this. If you hit enter, this is saying take my answer and convert it into a fraction. So it does, 7/6, which is what we found over here. So you could use your calculator when you're working with these fractions as well. So let me show you another way, maybe a faster way to solve this. So let me just recopy this again. I'm going to call it 1/6x at the start plus 2/3 is equal to 1/3 x minus 1/2. The fastest way to solve this would be to clear out the fractions and then just solve it as a normal equation. You do this by multiplying by the lowest common denominator. Here, my denominators, I have 6, 3, and 2, so my lowest common denominator is 6. So if I take each one of these expressions here and I multiply it by 6/1, multiply this by 6/1, multiply this by 6/1, and finally multiply this by 6/1. The 6's here are just going to cancel each other out, so I'm left with a 1x. If I cross-reduce the 6 with the 3, so cross-reduce here, get rid of the 3, the 6 becomes a 2, so now I have 2 times 2, which is 4. Again, cross-reduce the 3 with the 6, so the 3 is gone, that becomes a 2, so that gives me 2x. And then cross-reduce the 2 with the 6, that becomes a 3, that's a 1. Those all became 1s there. So 3 times 1, that gives me negative 3. Now all I did was multiply my equation by the lowest common multiple, and now I have no more fractions. So it's just simply a linear equation that we have to solve. So I'm going to minus 1x on both sides. So I get 4 is equal to 1x minus 3. And then we can add 3 to both sides. And you get 7 is equal to x. So notice you get the same thing. I think this version on the right is a lot faster. It takes some good setup and understanding what you're multiplying. So when you're multiplying by the lowest common multiple, you're actually multiplying the denominator or the numerators together and then dividing by that bottom number, the denominator. So like if you did here, if you did 6 times 2, that's 12, divided by 3 gives you 4. I just cross-reduced to save myself a step, and we can cover that again as time goes on here in class. Let's keep this moving. Example number 3. So let's do 2/3 y plus 1/2 times y minus 3 is equal to y plus 1 over 4. So this could look like there's a lot going on. Now, to start off, I'm going to distribute this half inside here. So I get 2/3 y plus 1/2 y minus 3/2 is equal to y plus 1 over 4. Now let's use that method that I showed you the second time in the previous problem. So denominator of 3, denominator of 2, 2, and 4. So my lowest common multiple here is 12. So I'm going to take each term and multiply it by 12 over 1. So take this, actually, let's move this. Let's say I'll move it over here. So take 2/3 y, multiply it by 12 over 1. 1/2 y, 12 over 1. 3/2, 12 over 1. And then y plus 1 over 4, 12 over 1. So, cross-reduce here. 12 divided by 3 is 4, so that becomes a 4. So you get 8y. 12 divided by 2 is 6, so that becomes a 6. So we get 6y. 12 divided by 2 again is 6. So we have minus 6 times 3, which is 18. And then equals, now here's the kicker. Because there's an expression in the numerator here, I'm not going to just multiply the 3 to the 1 or the 3 to the y. So if I cross-reduce, we get a 3. That's what I was talking about there. So we have a 3, and then we still have this y plus 1 there. So now, distribute. So you get 8y plus 6y minus 18 is equal to 3y plus 1. So let's keep solving this. Combine your like terms. 8y and 6y gives you 14y minus 18 equals 3y plus 1. Move your variables. So subtract 3y. 11y minus 18 is equal to 1. Oh, whoops. Silly Mr. Epperly. When I distributed here, that should be a plus 3. So plus 3, plus 3. This makes more sense to me now. That should be a 3. So keep this going. Let's add 18 to both sides. So you get 11y is equal to 21 divided by 11. and we get y is equal to, I'm just going to leave it like that, 21 over 11. Don't convert it to a decimal. Leave it as a reduced fraction of 21 over 11. Example 4. Let's have 8 minus 2 parentheses 5x plus 6 equals negative 2 parentheses 5x plus 2. So pause the video here, solve this, and then when you're done, press play and see if I get the same answer. All right, welcome back. So let's start by distributing this negative 2 here, kind of similar to the first example we saw. And again, distribute this negative 2 as well. So we get 8 minus 10x minus 12 is equal to negative 10x minus 4. Combine those like terms first. So I've got 8 and negative 12 here. So that's negative 10x minus 4 equals negative 10x minus 4. Now, some of you may see what's happening at this point, but I'll keep going. Let's move our variables. So let's add 10x to both sides. Let's add 10x. Cancel there. I get negative 4 is equal to negative 4. Now, when this happens, when you get a true statement at the end, that means that it's all real numbers. Or this symbol, this big R with the line through it. So this is all real numbers. That is your solution to this problem. Any number that you plug in, it doesn't matter what the number is, this would always come out to be a true statement. So determining if it's always true, sometimes true, or never true, this is always true. The reason being is because it's all real numbers. So this is always true. Now, what I was mentioning earlier is that if you look here, we have the same thing on the right as we have on the left, right? Negative 10x minus 4 is equal to negative 10x minus 4. You could plug in 0, you could plug in 100 for x. It doesn't matter because it'll always come out to be negative 4 is equal to negative 4. So your statement is always going to be true. Let's look at another example. We have 7x plus 6 minus 4x is equal to 12 plus 3x minus 8. So pause the video here, try this one on your own, and then come back to me when you are done. Welcome back. Let's start by combining like terms. So I've got this 7x and this negative 4x. And then on the other side, I've got this 12 and this negative 8. So we get 3x plus 6 is equal to 4 plus 3x. And then if I subtract 3x on both sides, the variables cancel out and we get 6 is equal to 4. Now, 6 is not equal to 4. At no point, I'm not trying to trick you here. Because all of our variables canceled themselves out and we got a false statement at the end, that means that there is no solution. Or you could have the circle with the line through it. So there's no solution here. The reason being is that this is never true. I cannot find a number that would plug into here that would ever make that statement true. So there's no solution, it's never true. So notice, comparing the previous two, all real numbers, that is your solution, and it's always true because any number could possibly work. But if you have no solution, then it's never true. And let's do one last example here. It's going to be example number 6. Negative x plus 2 parenthesis 5x minus 1 equals 2 parenthesis 3x plus 4 plus x. All right, so pause the video, try this, come back to me when you're done. Welcome back. First thing you want to do, distribute inside the parentheses there. So the 2 gets distributed on both sides there. So we have negative x plus 10x minus 2 is equal to 6x plus 8 plus x. Combine your like terms. You've got this negative x and this 10x here. So that gives you a 9x minus 2 over there. And then you've got 6x and 1x. That gives you 7x plus 8. Move the variables, subtract 7x. You get 2x minus 2 is equal to 8. Go ahead and add 2 to both sides then. You get 2x is equal to 10. And then when you divide by 2, because you're solving, you get x is equal to 5. That is your solution. Your solution is that x is equal to 5. Now, comparing it to, is this always true, sometimes true, or never true? Because we only have this one solution here, it means that this is a sometimes. The reason being is that the only time this expression is true here is when x is equal to 5. So it's sometimes true when x is equal to 5. But if x was equal to 6, then it's not true. See how I created a counter argument there? So if you can make it fail once, then it's sometimes. But if you can't make it fail at all, then it's an always true. And if you can't make it work at all, then it's never true. So make sure you have these notes copied down into your notebook, and we will talk about them the next time I see you in class. Have a wonderful